So when we're factoring, what we're doing is we're looking to see what is common to all of the terms, and then we're taking that out. Now, and then we're rewriting it. Now, sometimes it's fairly straightforward. There is something common to all the terms, and it's just one thing that's common to all the terms, or sometimes it might be two things. But sometimes it's also it's a bit of an expression in and of itself, which is what we're seeing happening with these two here, and we'll go through those in a few minutes. But essentially, what we're doing is we're doing the opposite of expanding. So we're looking for factors within the terms that are common, and like I said, sometimes we can't really see what's common to both of them. So we're looking for an expression of itself. So over here, we have, look at this, we've got 9x squared plus 3 times x times y. Well, this is made up of 9x times x. This is made up of 3 times x times y. So 3 is common to both of them. So we're going to take that 3 out. So we're going to say 3. X is also common to both of them. So we're going to take out an x as well. And now we're left with 3x. And plus, I'm going to say y. Because that's what we've taken out. So we've taken out that 3x, we bring it out the front. 9x squared divided by 3x gives us 3x. 3xy divided by 3x gives us y. So that is that thing factorised. I'm just going to put a line here. Hopefully make it a bit easier to read. We may also need some more working out space. Very similar here. We've got 7x squared, 49x. What numerical factor is common to both? Well, 7. 7 is common to both. So we're going to take that out. Also, we've got an x here, and we've got an x here. We've actually got an x squared here, so that means we're going to take out an x, and we're going to say we are left with x plus 7, because 49x divided by 7x is 7. And we can always check by multiplying these out. So just to check, 3x times 3x gives us 9x squared. 3x times y gives us plus 3xy. So it doesn't matter how long it is, how many terms we've got, or whatever the case may be, that's where we go about doing that. We look and see what's common to both of them, and then we factorise accordingly. Now, sometimes it gets a little bit weird. Like I said earlier, when we've got things like this, we don't actually have one thing. As we see here, we've got an x squared, and here we've got a 16. Nothing is common to both of them. Here we've got an x squared, and here we've got a negative 3. Also, we've got minus or negative. Nothing is common. It's not obvious what's there. So we have to apply something. Now, as soon as we see a term like this, I'm going to write over here. I'm going to change colours. I'm going to write in green. As soon as we see a squared minus a b term, we can turn this into a squared by taking the square root of that. And as you may remember, this is a difference of two squares, or difference of perfect squares, which tells us that if we've got a squared minus b squared, that factors to a plus b, a minus b. So over here, this is our a term, and this is our b term. And remember, this is already squared, so we've got to take the square root of this and then square it. So that's what we're going to do here. So we're going to take the square root of that. So we're going to say that it becomes x squared minus 4 squared, and we are left with x. I'm going to give myself some more room. And we're left with x plus 4, x minus 4. Likewise for this thing here. We've got our a term, we've got our b term, squared, squared. So we've got to take the square root of this, so it becomes square root of 3. So this is x squared minus the square root of 3, and we'll square that. So then from there we're left with x plus the square root of 3, and then x minus the square root of 3. So it doesn't matter what it is, what it looks like. If we've got a squared term, and we've got a numbered term, and we've got a minus in the middle, we can we can apply a difference of two squares. That's pretty much what we can do. So now if we were to multiply these two things, x plus 4, x minus 4, we end up with x squared minus 16. But as I said, we're looking at splitting it up into factors. Sometimes it's very obvious, like what we've got here. Other times, not so much.